All right, I'm going to spend a few minutes talking about 2.5 axis toolpath creation in Rhino and RhinoCam. This is our object. It is a 1-inch thick piece of MDF that we are going to cut a hole through and cut a mill pocket into. I've offset it by 1 inch from our 0, point. I'm just going to draw a 24 by 24 square. And this is our material. I'm going to change the layer that's on so we know that that's the reference. So this gives us plenty of room to put a screw in the corner, and it also gives us plenty of room for the bit diameter to still leave material behind so the material doesn't get cut all the way free in the middle of the cut. Okay, object placement. If you haven't, if it's not open already, go into your RhinoCam tool menu and open your browsers. Go to the knowledge base as we've done before. We're going to choose wood, plywood, MDF. In this case, looking just at 2.5 axis wood or composite. And I know that I'm going to need to cut this whole object out, so that's profile, and this hole we're going to have to cut, that's a profile, and then we're pocketing. And in the order we want to do it, we want to pocket first because nothing comes free. Then we want to cut this hole out second, because if something comes free, the whole object is still in place, and then we want to end with the total profile. So we're going to start, let's see, all right, so that's how it works. Pocketing. So we want to start with pocketing and then do 2 profiles. And I think we were doing so we already have the tools in here, that's fine. Okay, so the first thing we need to do is be able to tell the program what to look at when it's milling, how to define its milling region. So I'm going to do a mesh outline here. If I didn't retain my curves, and I'm looking at this, I'm seeing that this curve and that curve are at the z equals 0 plane, and I want those, but I don't want this bottom one. All right, so select this, and that, and just to keep track of it, I'm going to change the objects layer. Okay, so right now we have 2 curves. What we don't have is a curve for this region, and it's easy enough to generate by doing a dupe edge. Let's duplicate edge and select that edge, hit enter. While it's still selected, I'm going to change its layer, and we are good to go. We have 3 regions. Okay, so we'll start with pocketing. I'm going to go from top to bottom here in the menu. Options, machining features, selecting the region, and I am pocketing this region, hitting enter, and I'm going to save, and then I know that this is the bit I want to use. Feeds and speeds and clearance geometry are defined in the knowledge base, and I don't want to change those. In parameters, there are a few things that are worth looking at. One is where the cut starts. It can cut on the outside, so in this case, it can start to cut from out and work in, or go from in to out. It doesn't matter right now which one we do. So by default, it's on inside. Tool diameter is how aggressive the step over is. So imagine this will be concentric circles. You don't want to use a full bit's diameter to be cutting. It's a little too much load on the bit. So 25% is reasonable. Cut levels, I want to go halfway through, so I'm going to type in 0.5. We still want the rough depth to be 0.5 and the finished depth to be 0. And then each step down is going to be 0.15, which makes sense for a 0.25 bit. It's about half that, and that's the right kind of load on the bit. So I'm going to hit generate and see what we get. So you can see we have a bunch of concentric circles, and then we're stepping down 1, 2, 3, 4 times. All right. So if I went in here and I changed this to 10%, for some reason I felt that would give me better resolution, you'll see that the density increases. And keep it at 25. All right, we're done there. So profiling, let's say we want to cut this inner portion out. First, select the containment region and save there. Again, the bit, feeds and speeds, clearance geometry is all going to be kept the same. Parameters, this is where we go to cut levels, and again, 0.52. We want to go all the way through, so we're adding 0.02 to the thickness of the material, and it's automatically calculated an ideal rough depth per cut. All right, advanced cut parameters, I might want to go here and modify the bridges. I'm going to leave them as default for now, for this one. It could be that with a cutout on the inside, I don't want to do as much sanding, so I change this to 0.1. Let's do 0.1 length and 0.15 height, and then maybe I do 3 instead of 4. Okay. Something is going on. There we go. It's hidden by the geometry. So you can see something is a little bit wrong. The orange line is the geometry, and you can tell that we're actually cutting on the outside of it. So what I want to do is go back into parameters, and then I've got this option that I forgot to click, and that you will forget to click from time to time, and you'll want to just double check what's going on visually on your screen. So we want it to cut on the inside of that line. So if we change that and regenerate, we're now going to see these tool paths on the inside. And you can see here at the bottom, we have a tab. I've made another mistake, and I had the pocketing depth in mind. What I really want is to cut 1.02. Okay, so now that looks right. Fair enough. And then we've got one more to do, the outside profile. Save that, same as before, and in parameters, this one we actually do want to be on the outside. We want the cut levels to be 1.02 to go all the way through. That is regenerated the way it should, and I'm going to keep these at 0.2, 0.2, and 4. I want them to be a little bit larger. I don't want the piece to come loose, and it's very easy to sand that edge. Okay, so we can turn this layer off, and we see we're going down on 1, 2, 3, 4, 5, 6, and we can see the tabs in the setup. Okay, pocketing, profiling, cutting on the inside, profiling, cutting on the outside. And you can see in the top view, profiling, cutting on the outside, the blue line's outside the yellow, and the blue line is on the inside of the yellow or orange when you're profiling on the inside. And this is the concentric circles I was telling you about. Okay, so it's always a good idea to double check everything is working well by defining your stock. So we want to set this to 0, 0, 0, and we have 24, 24 by 1 inch stock. And we could, in this case, simulate, which we haven't done before as a class. And I'm going to go ahead and press play. Wow. And it's a very useful thing to ignore the choppiness. Run that again. And if anything looks funny, you just go back and check everything out. Okay, there you have it.